Hello everyone, Mr. Fugay here. This video is a help video if you are having any trouble on any problems on the 10-1, 10-3 study guide on trig ratios. So we split it up into three sections. So this first part is on section 1, which helps with the special right triangles. So we have two examples. Example 1 here, since we have a 60-degree angle, a 90-degree angle, this then by default has to be 30. So we're working with a 30, 60, 90 triangle. We need to concern ourselves with this triangle down here and draw on a comparison between them. So first step is to compare each of these ratios with the sides that we already know. Since we know the 3 is the hypotenuse, we know that that will be equal to 2n, since we're setting it equal to that corresponding side. While the other two aren't as important, we're still going to do them. The across from 30 is labeled y. We know that that's going to be equal to our n. So once we solve for n, we can just simply plug it in and be done. And then lastly, the x side is equal to n root 3. So those will come into play in a little bit. But the most important part is that we're going to see this relationship right here. And so solving this, you're going to divide both sides by 2. And when we do that, we're going to get n equals 3 over 2. So this helps us a lot here because now if we ask what x is going to be equal to, well, y. Let's start with y. Y is equal to whatever n was. And so right away, we know that the side y here has to be 3 over 2. Now let's talk about the x. The x that we need to find is equal to n root 3. But since I already know what n is 3 halves, we can substitute that in. So that makes this 3 halves times root 3. Now, if you're not sure how to write that, technically you can write it that way, but root 3 is a fraction over 1. Any whole number or any number can be written over 1. So if you multiply the numerator with the numerator, you get 3 root 3. And then if you multiply the 2 times the 1, you get 2. You can, of course, use your calculator to help with this as well, but ultimately, that's what we need to do to solve for 30, 60, 90. Let's try a 45, 45, 90 now, shall we? So in this problem, we're going to use this triangle here circled in blue. And so we're going to compare our three sides to that 45, 45, 90 triangle. So 4 is, in this case, the hypotenuse or the longest side since it's across from the 90. So we're going to say it's equal to n root 2. Y would then be equal to n, and x would also be equal to n. So our whole job here is to solve what n is, and then that will be able to answer what x and y are going to be. So to solve for n here, we would divide by root 2. You can use your calculator if you would like for this, but we're going to get 4 over root 2 as our answer. However, we do need to rationalize this, and so to rationalize, let me move that equals n over. The trick here is you're always going to multiply top and bottom by the square root you would like to move. So in this case, root 2 over root 2. So we get this is our n, 4 and 2 cancel the 2 and 1, and so our final answer here for n would just be 2 root 2. And this is why, in this case, this is super helpful, because if you know x and you know y, well, x is equal to n and y is equal to n, so quite literally all we're going to do is insert that 2 root 2 answer, and that's going to solve for our missing two sides of the right triangle. So that is section 1 help. Feel free to pause and go back to any parts of this. We're now going to move on to part 2, and part 2 talks about the reciprocal trig functions. So let's look at our reference sheet here. Our reciprocal trig functions are essentially going to be these three right here. So cosecant, CSC, is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. If you know your sine, cosine, and tangent ratios, all you really have to do then is remember which ones are the reciprocals. So let's look at 3 problems involving this. In the first question, they're just asking you to find the fractional ratio of secant of theta. Well, secant is the reciprocal of cosine, and cosine is adjacent over hypotenuse. So we're just going to simply label the fraction whatever the hypotenuse is and whatever the adjacent is. 20 is my hypotenuse. Here's theta. Don't forget where theta is located. Opposite is 16. Adjacent is 12. So in this case, my answer would just become 20 over 12. That does simplify, however, because 20 and 12 both go into 4. So this would end up becoming a 5/3 as the simplified fraction. In the second one, we're going to look at cosecant. Now, cosecant, let's write that down here, is the reciprocal of sine. And sine is opposite over hypotenuse. So we're going to flip it and write hypotenuse over opposite. Here's my theta again. Therefore, 6 is my opposite, 3 root 5 is my hypotenuse, and 3 is going to be my adjacent. So in this case, my hypotenuse would just be written as 3 root 5 over, and then my opposite in this case is 6. 3 and 6 do go into each other, so that goes into 1 and 2. And so our final simplified answer for this question is going to be root 5 over 2. Root 5 over 2 as our cosecant. Last but not least, we're going to see an example of cotangent. And there's a little curveball in this one too. But let's begin and let's find out where that curveball lies. So cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. And so in this case, cotangent would be adjacent over opposite. So if we label our sides, 20 is opposite, 15 is hypotenuse, but we have a problem. We don't know what our adjacent is. And so because we don't know what our adjacent is, we will have to employ the Pythagorean theorem here. So it's 20 squared plus, then this we'll just call, I don't know, x squared? Sure, we can use any variable we want, so we'll call it x squared, equals 25 squared. So we're going to get 400 plus x squared equals 625. Subtract 400 from both sides. X squared is going to be equal to 225. And upon taking the square root of 225, we're going to get an x value here of 15. So now we know our adjacent side is going to be 15, which now will allow me to set up the cotangent ratio the way that I want. So my adjacent, once again, is 15. My opposite is going to be 20. And upon simplifying, they both go into 5. So this is going to be 3 over 5. My pen got angry there. 3 over 5. And that's going to be our final answer for the cotangent ratio. So this was help on section 2 of your study guide. I believe those were problems 5 through 8. So feel free to go back to these examples to look at key points and use them in your own problems. And for the last part of the video, we will be looking at section 3. The first question will be similar to what numbers 9 and 10 looks like. And then the last example I do will be similar to number 11 or 12. So here we go. This is similar to 9 and 10. So given the terminal side that theta goes through the following point, let's find all 6 trig functions. So the first thing we need to do is we need to draw a picture. So negative 4, 7, because x is going to the left, y is going up. This is going to put me in quadrant 2. But when you go ahead and graph this, you can see 1, 2, 3, 4. And then we're going to go up 7. So 1, 2, 3, 4, 5, 6, 7. So my point right there, negative 4, comma 7, is located here. Draw a straight line for that terminal side to the origin. And you can see that we've created a right triangle here in quadrant 2. Theta will always be on the origin. The leg here was a negative 4. We do have to denote negative and positive numbers on the coordinate plane, but we do not know what my hypotenuse, or we're calling it the r value, is. So we will need to set up a Pythagorean theorem to solve for this. Negative 4 squared plus 7 squared equals r squared. Don't forget, when you square negatives in your calculator, you need to put it in parentheses, or a hint here is all negative numbers, when they're squared, will always become positive. So this becomes 16 plus 49 equals r squared. We will add those together. I don't think that comes out to be a perfect square. It does not. It gets very close to being a perfect square. And then we're going to take the square root of those sides. So this is going to just be square root of 65 as my r. So let's go ahead and write that. And there is my 3 sides of my triangle. Let's label opposite, adjacent, hypotenuse. So this is opposite, this is adjacent, this is hypotenuse. And remember, you could use the x, y, and r definitions that are also provided on our reference sheet here. So you could see that, for example, negative 4 would be my x value, 7 would be my y value, and then the root 65 is my r. So you could use those alternate definitions, but if you're familiar with opposite, adjacent, hypotenuse, that's totally okay as well. So let's go ahead and let's write out those ratios. That would be tangent. Okay, so sine is opposite over hypotenuse, so this would be 7 over root 65. We'll come back and talk about simplification at the end. -4 over the root 65. And lastly, tangent is going to be opposite over adjacent, so -7 over 4. Let's go over and let's do our cosecant, our secant, and our cotangent real quickly. And then, like I said, we'll talk about how to simplify these. Cosecant's just the flip, so it's root 65 over 7. The next one is going to be root 65 over -4. And then the last one is -4 over 7. So you're just taking the reciprocals to get those three answers. Now, in terms of simplification, if there are any radicals in the denominator, we should simplify these. Again, you can use your calculator for this if you want. If you type it in with the radical, it should rationalize it for you. But if you don't know how to do that, or if you just simply want to do it by hand, remember, we're going to multiply this way. We're going to multiply root 65 over root 65. So this will become 7 root 65 divided by 65. And then for cosine, we're also going to need to do this because there's a radical in the denominator here as well. And that's going to give me -4 root 65 over 65. 4 and 65 don't go into each other, just like 7 and 65 don't. So those are just going to simplify as is. And all of these other answers are all going to be our final answers for the 6 trig ratios at -4, 7. And our final example will be similar to numbers 11 and 12 on your study guide, and that is where I give you one of the trig functions and I tell you what quadrant it's in, can we find the value of the other 5 trig functions? So right away, because we know the triangle's in quadrant 3, I'm just going to put a random point here, draw my terminal side. Remember, the drawing doesn't have to be necessarily to scale, so I'm just going to draw a triangle in quadrant 3 like they tell me. My theta is going to be here. Since sine is the opposite over the hypotenuse, I know the opposite side of theta will have to be 2, and the hypotenuse side is going to be 3. Because we're in quadrant 3, that means that the y value here, the -2 that is going to be negative. Whatever answer we end up getting for this, when we do Pythagorean theorem in a minute, will also have to be negative, because in order to plot this point right down here, in order to do that, you have to go left, which is a negative value, and down, which is a negative value. So keep that in mind. Let's do our Pythagorean theorem to find our missing part, and then we'll go ahead and find those trig functions. So it's going to be -2 squared plus, we'll call it x squared, since it is technically our x value, equals 3 squared. We're going to get 4 plus x squared equals 9. And when you subtract that, you're going to get 5. Take the square root of both sides. And so x is equal to the square root of 5. And there we have it. Notice I made that a negative value. This is opposite, this is adjacent, this is hypotenuse. So let's go ahead and let's get these finished up. Hey, let's do sine, cosine, and tangent first. Opposite over hypotenuse, we already knew that, it was -2/3. Cosine is going to be -5 over 3. And then my tangent is a -2 over a root -5. But since they're both negative, let's just go ahead and save ourselves the time. I don't know why that's glitching. Sorry about that. We get 2 over root 5. Finally, let's do our cosecant, our secant, and our cotangents. So this becomes -3 over 2. This becomes -3 over root 5. And the last one becomes root 5 over 2. Almost final answers here. There's only 2 of them we got to rationalize, and that is the tangent answer and the secant answer. Let me rewrite secant so that it's a little more properly written. I wrote that very quickly. Okay, so we're going to go ahead and rationalize these to wrap up. We're going to multiply by root 5 over root 5, 2 root 5 over 5. Remember, if there's a radical in the denominator, we need to rationalize. Otherwise, it's good to go. All those answers I've boxed in are good. And here's our last one. It'll be -3 root 5 over 5. And we have all 6 trig functions in this given situation. So please go back to any parts of this video, whether you need help on section 1, 2, or 3, where I'll have plenty of examples where we'll walk through these. Hope this video helps, and have a great rest of your day.